SOLIDWORKS Motion is the standard virtual prototyping software inside SOLIDWORKS that helps designers and engineers understand how their assemblies perform. An add-in inside SOLIDWORKS, SOLIDWORKS Motion works seamlessly with the assembly you build. We will simulate the movement of a 6-axis robot to complete the predetermined path it needs to follow. SOLIDWORKS offers you 3 levels of simulation. The first level, called Assembly Motion, allows you to apply motors and key points to simulate the motion due to assembly mates or constraints. Physical simulation, the second level, provides a more realistic simulation with motors, springs, contact, and gravity. The third level, SOLIDWORKS Motion, gives you the most realistic simulation with all the motion objects and numerical results. Because SOLIDWORKS Motion understands most SOLIDWORKS mates, you can simulate the movement of mechanisms as you build them. With the various motor actuator functions available in SOLIDWORKS Motion, you can move any assembly component with a particular motion profile. All motion objects are accessible through the Motion Manager toolbar. You can apply a motor with the following profiles. Constant speed. The motor speed is constant. Distance. The motor operates for a set distance and time frame. Oscillating. You can enter the values for the amplitude and frequency. Interpolated. You can load the values from an interpolated function. Expression. You have more complex result-oriented functions. In this example, we will load a motion profile for motor number 1 from a file. The Animator timeline provides you with an easy and powerful way to organize the driving items, rename the objects, and review motion inputs. During the simulation, you can turn the motors, mates, or constraints on and off. SOLIDWORKS Motion enables you to define other motion objects, such as springs, including torsion springs, linear and torsion dampers, forces and moments, 3D contacts, and gravity. You can also request output quantities, including forces, moments, torque, velocities, accelerations, and displacements. Dynamic XY graphs are available for all these quantities, giving you qualitative results at your fingertips. You can track the path of any location on the model. During its operation, you can get visual feedback of any interference in the parts. SOLIDWORKS Motion allows you to export animations as AVI files, so you can quickly and easily share your designs with your team. If you need to perform a stress analysis on any part, SOLIDWORKS Motion lets you transfer forces and moments to SOLIDWORKS simulation. As you can see, we have exported the forces from SOLIDWORKS Motion into SOLIDWORKS simulation to investigate the stresses and displacement on the part due to motion loads. After running the stress analysis, we find that the maximum stress in the model is around 27,000 pounds per square inch. Now we are going to make a simple design change to this part by adding a rib, which will strengthen the area around the high stresses. After this, we can quickly rerun the motion simulation for this modification and recalculate the stresses in the model. Now the stress results have come down to 22,000 pounds per square inch, which is around an 18% reduction in stresses. That will increase the life of the part for more operations. You can use SOLIDWORKS Motion for a wide variety of applications. Find total torque force on motors and actuators to drive any motorized mechanism. Optimize springs and dampers. Simulate cam drives and latch mechanisms, as well as investigate gear drive motion and calculate contact, impact, and collision forces. SOLIDWORKS Motion is included inside SOLIDWORKS Premium, SOLIDWORKS Simulation Professional, and SOLIDWORKS Simulation Premium. Using SOLIDWORKS Motion early in your design cycle helps you shorten product development time and reduce physical prototyping costs.